Brian Friedman. You've worked here at I think Pivotal, Tanzu, VMware Tanzu by Broadcom with me for a long time. I mean, not with me, in the same organization. And I think you started off doing some labs work. What did you start off doing in this area?
Indeed. Thank you, Michael, for having me on and for picking my brain a little bit. I started my adventure here with Broadcom through Pivotal, as you mentioned, about 7 years ago. And I came in as what they called an application transformation consultant. So my job was to go find go help our customers that had just purchased Cloud Foundry get, in my case, .NET workloads on the platform, as many of them and as quickly as possible, because 7 years ago, the Kate's wave hadn't quite erupted yet. There weren't many on-prem private cloud solutions, and Cloud Foundry was best of breed. And so we wanted to make sure that investment was realized quickly and to prove to our customers the efficiency of the platform and really all the gains available to them and to their developers.
Yeah, I think this is something that it's obvious once you've been doing it for a while. But whether you're on let's call it the buy side or the sell side of platforms, is that they very quickly, quick in an enterprise is several years, but they easily become, shelf word is the wrong reason, but they become great edifices that very few applications live in, unless on both sides you do a lot of work to drive usage, right? It's not people like to use that field of dreams thing, which is fine, and so I think that is a lot of the work that I see people who are running platforms. What they kind of discover after the first year is, there's a lot of attention put on it, and then you need to get more apps, which I think is interesting. And one thing in particular you mentioned, I think, I don't know, what's up with .NET and C# applications in there? Give me a sense of how widely those are used. They seem kind of like a underappreciated, underspoken about thing in the enterprise app space, or maybe that's just me.
Yeah, absolutely. So I want to touch on two things. The first thing that you mentioned, I wholeheartedly agree with. Platforms and all kinds of things becoming shelfware. And I think the resonating message that many of us, I don't know if we refuse to hear, but we simply just don't like to hear, is that the tool doesn't fix the problem. It's how we build the tool that fixes the problem. The human element in leveraging that tool and all of its goodness is where you're going to get the result. The tool is not the check, right? Writing the check for the piece of software is not the effort. That's just the start. Yeah. The effort is going to involve some planning and some adoption, some experimentation, maybe.
Spoken like a true labs person. Very, very, very nice.
So thank you for calling me out on that. But I also want to, what about .NET? And that was, so I kind of discovered when I got this gig as a solution architect for .NET app transformation, I discovered a few secrets. First of all, there's a lot more .NET in the world than folks would like you to believe. The reason it can be such a kind of a well-hidden silent player in the world is because most of .NET grew up in a walled garden. Most of .NET grew up where it didn't have to interact with anything other than another Microsoft product. And the integrations tended to be pretty well done, right? This is a company that's basically giving you the tools to construct a pipe between two facilities that it's designed, purpose-built for that pipe.
Right. It's supposed to be like a fully functional platform, has everything that you would need.
Yeah, it's not to date myself, but it's where you were in 2005 with your iPhone, your iPad, your Mac, that walled garden of things that work perfectly together. No other outside vendors were allowed to inject any lack of quality into that mix. It was a very controlled environment. But the rest of the world has a lot more freedom when it comes to development. Python, Java, all these kinds of these developers have just this smorgasbord of componentry to pick from. Some of it safe, some of it not, but all of it open source, and they can pull it all in to kind of help get various jobs done. But those jobs can get done in very different
Yeah.
ways. And when you compare that to older .NET, I particularly find older .NET quite a bit easier. It was Einstein had 7 of the same suit because when he woke up in the morning, he didn't want to have to make decisions about what he was going to wear. I had a lot of .NET developers that didn't have to make decisions about what component they were going to use. If they wanted to get a job done up until a certain date, it's going to be a pretty limited supply of what their options could be, which in my view made my job easier, fewer decisions.
Right.
There's a
.NET
ton.
only has 7 suits in its closet, which is
That's right.
helps it out.
Every doesn't have to pick what it's going to wear, and to Microsoft's credit, the C# is just one of many languages you can write for the .NET framework in. To Microsoft's credit, as they've evolved from what they're really good at making software. I don't think they're so good at naming things. We've evolved from .NET to .NET, right? And in the middle of that, there was .NET Core. So for those of you that might not know, the first .NET, many of us call legacy .NET or full framework .NET. This is the version of .NET that runs only on Windows and loves Windows. There was a about 5 to 7 years ago, there was an effort to move from this .NET Windows only runtime to .NET Core, which can be run on Linux and many other, Star Unix flavored operating systems. That's a huge deal for a Windows developer. But now the .NETers are in very much the same boat as the Java folks. There are tons of ways to do things. There are so many interchangeable, interconnectable open source projects that it's really incumbent on those .NET developers who maybe haven't gone through all of the same thorny bushes as Java developers when it comes to open source componentry and transitive dependencies and how's this going to work with that. I think .NET developers are going to start feeling that pain if they don't have more guardrails in front of them than the Java devs had when this whole software revolution started a couple decades ago.
And do you think these, like, speaking in broad terms, like .NET developers have not necessarily participated in, let's call it, like, the platform as a service or the kind of platform, I don't know, thing, or I could put it another way, an older way, kind of like the cloud native microservices, I don't know, deal where you're integrating with it, as you were kind of indicating, a whole bunch of other things that are out there.
There's kind of two sides to this. One is an absolutely brilliant framework called WCF, the Windows Communication Foundation. Definitely an old school .NET concept. They rewrote it in Core. But the idea behind WCF was to completely separate the wireline protocol from the business logic that was being activated.
Right.
So to have a service that could be hosted at an HTTP endpoint, or maybe drink from a queue, or maybe it's hosted in proc, right? And you're actually calling this private service in the same way you would something that's on the other end of the world, but you're doing it through a name pipe in your own memory space. So the idea of microservices and a flexible environment as far as deployment architecture goes is not new news to .NET developers. However, I will say without exaggeration here that the first engagement I was on, 16 weeks with a very large financial services company in Middle America, the closest thing I saw to tears from that group was when they CF pushed. CF push is the command to get my bits to the destination environment. Now, if you've never worked with IIS before, and you've never tried to push an application to a naked IIS server and get your application URL back and go start exploring that application, there's a number of steps involved there. And depending on the enterprise you work in, your grubby little fingers probably don't have access to all the buttons because separation of responsibilities, especially in a financial industry. To be able to type in a command line to a lower environment and receive back a URL and then paste that URL into your browser and start testing, literally almost tears. Just people that were just so enthusiastic to see a change so quickly after they coded it locally. I was a little bit mind blown to see them that excited, but then I kind of started to realize what they've been going through. Prior to that 16-week engagement, 16 weeks might have been the amount of time between the last line of code they wrote and the amount of time it took for it to get into a UAT environment.
Yeah, it's a delightful like nerd feel to see like a developer very excited about like some unexpected toil removal and just like getting their what did we used to call it, an inner loop? I forget all the loops, but yes. getting their inner loop thing to be less frictionful, which I don't know. We enjoy that ourselves, and to see that joy in other people is always good. Now that's a good setup to like. I think in recent years, you've spent a lot of time talking with these organizations about modernization and like legacy stuff and all of that sort of thing, right? And so, if we have that mindset of a more difficult way to deploy and architect and do apps, and then someone wants to like modernize their entire approach. I mean, even entire is a little bit of a weird word there, but like what, someone comes in and they're like, the way that we're doing applications, we need to improve for whatever reasons. Like, what do you think they often get wrong about their mindset when they approach this? Like, what are they not thinking about when it comes to planning out their, let's call it, modernization efforts?
Yeah, I think there's probably three things that come to mind. One is the point that was brought up earlier, which is the tool doesn't do the work. The tool is for your hands, and your hands do the work with the tool in hand. So just simply making the purchase doesn't solve the problems. That's typically problem number one. Number two tends to be kind of just this, we're ingrained in the way we've been doing things, right? So when we ask, how do you deploy an application, and you get through this whole conversation, and then you find out at the end, oh, that's only how you deploy a Java application. Did I need to qualify that question? How do you deploy a Python application? How do you deploy an R application? How do you deploy a Windows app? All these different paths to production. Right. So it's really hard to solve a company-wide problem when you've already kind of got this sharded, fragmented approach based on what language people use. And it's kind of funny because the language is just the build phase, right? The language is just building down to either interpreted or binary. Like it's either an interpreted language or for a runtime, or it's binary. So really, shouldn't the build process be the only thing that's different?
Yeah.
Everything else feels like it should be very much the same. And so,
I like this notion of, instead of saying silos, saying shards. like that's an interesting distinction, right? In the sense of, because what you're saying is, making me think of a common thing that I think happens, and I've seen over the years, is in trying to modernize how you're doing your software. I don't know. This is a negative way of putting it. You don't really realize how much of a mess there is, and you could replace the word mess with how much optimization has done on individual use cases and businesses to perfectly satisfy the needs that those applications have. Which is to say, there's a lot of variability in how just commonplace things are done that now you've got to deal with.
Yeah. You can put on your consultant hat and just call it lots of opportunities.
That's right.
Lots of opportunities. And what's funny there is that we've just all been doing it so long that we don't realize it's sharded. We like to think it's siloed, but you don't build a new silo for every new field. You don't sort, as long as it's grain, it goes in the hopper. But for us, did the grain come from the .NET field? Did the grain come from the Java field? But we're already looking at binary at this point. We're already looking at compiled, interpreted stuff. Why so much decision making over the route that it takes to production? And then I think, if I had to pick kind of a third thing that kind of gets in the way, and really this has become a problem for software companies that make things like what we make, right? So the developers gain so much from the platform that we offer. But guess who's not writing the check for the platform? The developer. It's usually an operations budget that's going to fund that platform. And so the idea that the customer that gets a lot of benefits doesn't necessarily have a large voice in the budgeting process for that particular aspect, what that's kind of come down to, in my opinion, is that's where it's brought this kind of cloud first or cloud or nothing approach, right? Because the cloud has all this built-in stuff in it. It's got all the answers. The answers are all right there. And then if we can just get this tool that, remember, if we've got this mindset, if I buy the answers, then the tools just fit in my hand and they work. That becomes kind of the next downfall, right? Is nothing we've tried on-prem has worked. But these geniuses that have managed to build their companies to these near $1 trillion valuations, they certainly know how to make it work. Maybe if we put it where they put their stuff, ours will work like theirs does. And for better or for worse, we've gotten some of that, right?
And do you like how unrealistic? I don't know how you answer a magnitude question like this, but like how when does a technology just sort of fix things, right? I didn't live through the, well, I mean, I lived through this time, but I wasn't involved in at the time, just sort of like the virtualization era of the 2000s. I was doing other stuff. And my understanding of virtualization is like, it just fixed stuff. Like you didn't have to like revolutionize your culture or go read a stack full of airport business books to get the value of virtualization. It just worked. And so,
you know why? There's a very specific answer there. Nobody's workflow changed.
Right. And so there you go. I mean, that when you're doing modernization, how is it that the workflow changing affects what you need to do?
That's everything. I mean, you have 100% nailed it. It is the people. The biggest risk to any modernization project is collaborative risk. The more collaborators, the greater the risk. This is people depending on other people to get things done. And the way that things have been kind of structured, the folks that should be talking every day synchronously typically end up talking asynchronously once a quarter.
Well, that's an interesting distinction. I mean, because if I draw it out, infrastructure, I mean, of course, things seem different depending on where you are in the stack, but infrastructure requires less coordination among people. like maybe it's a little more like straightforward and homogenized, but there's it's half metaphor, half actual for about software, which is like software is really people, right? Like it's people expressing things and writing stuff. And therefore, there's lots of dependencies with it. So it's like a whole different thing than like making sure you have a bunch of storage, right? There's a bunch of, I don't know. I'm kind of making a, what do they call it? A dog's breakfast out of that reasoning. But
no, I think you've nailed it. I think there was this whole excited moment of pets versus cattle in the 2000s when IaaS, when infrastructure as a service became a thing, and I could, through keystrokes and scripting, stand up practically an entire data center in just a matter of weeks. And if a server died, I didn't need to have a little pet funeral for it. I could just very quickly replace it. Nobody had to get woken up, maybe, depending on how my automation
or how
looked.
cruel you wanted to be. Just wake them up gratuitously.
Right, exactly. But applications never made that leap. applications are pets. They have names. They have homes. They live in repositories. They have families, developers. They have plans for the future, roadmaps. These are as pet as they get. Uh, and I don't know that we'll ever get to cattle because each of these things is serving a very distinct purpose versus infrastructure. When you look at it, there's just a few different flavors. There's things that are routing, there's things that are storing, there's things that are crunching, but these applications are taking this routing and storing and crunching and they're meshing it up into various use cases that are all distinct from each other. And so there becomes this point when you realize that, this is where Conway's law comes from. The idea that our communications, the paths for our communications in a corporate sense are going to be reflected in our communications in our software. And so you get this kind of common foundation in infrastructure, but then you still have the problems that are exhibited by how folks communicate internally, which end up manifesting themselves in how the software integrates.
So if we take the you got sharding, good stuff. I like this notion. Applications are pets, right? Like developers often name their releases, and I think operations people are just like, I don't know, that's US East 92B 67.
It's not Charlie anymore.
And
yeah, exactly.
And here's like a six digit GUID that we just attach to it for safety. And so what in the work you've done with organizations doing this, how much let's call it unpetting do you think is possible, right? Like you kind of go in there and you're like, it's fun to like have this as a pet, but really you don't need to do that, right? Like you kind of alluded to this earlier, just to throw we'll really get down to the metaphor here, just to throw you a bone. The build pipeline, like that probably isn't going to make your company's enterprise value go up or down. Like which build tool you use,
right? But how quickly are you using that build tool to get out to production is going to matter.
Sure, absolutely. This stuff has to work.
And in today's world, man, am I glad to not be plugging in hands-on keys for my first year in the biz in the past few years, because the bad actors out there, it's incredible. A CVE comes out and there are folks driving scripts just to try and find out if you're vulnerable, not so that they can pwn you, but so that they can create some identities in your infrastructure and sell to someone else the ability to pwn you. There is now an entire marketplace around a developer's bad day, a whole marketplace around one line of code skipped, or one bad dependency included, or one person not remembering the trauma of Log4j, right? Like it just takes one. And so I feel that developers today are walking on more eggshells than ever. They have to be more careful than ever. And while I don't know that there's ever going to be a moment where tooling or technology replaces the fact that applications are pets, because they're doing very specific things for us, that we're treating them like pets, but in how we manifest their behavior and in how we integrate and in how we validate, for instance, that the pet's behavior is what we believe the pet's behavior is before we let it outside, right? It becomes even more important that all of the steps in the software lifecycle are not corners cut, but are actually executed. And when you feel that that's a corner that's not worth your time, maybe that's an area where a tool can be helpful. I'll give an example. AI right now is, I don't know if you've heard about this, Michael, but there's a lot of people interested in this thing called AI lately. And one of the things that they're really interested in is, can it write all my code? Can I just fire all my developers, have something else take care of my pets? unfortunate news for those that kind of want to do that is there's no formula for building software. There is no formal spec, such as the building that I'm sitting in, and hopefully, Michael, the building you're sitting in, and hopefully all the folks watching this content are sitting in a building that has been walked through by an inspector and certified for occupancy. And the only reason the inspector can do that is there's a common checklist that all the builders are following. If I want AI to build me a building, I trust it to do that because there is an engineering spec and hundreds of years of human practice and math. If you want software, the possibilities are limited by the developer and the keyboard. You tell me how that's something that AI is going to turn into something that is frameworkable, like English grammar or any language grammar, right? Where it can assemble these really impressive responses because there's a framework. But when it comes to code, it's just what did people do? And whatever people did before, maybe I can try and do that again. Because we don't have a formal standard and because there is no actual unopinionated checklist as to what is a piece of software and how is it constructed, the possibilities are endless. And when the possibilities are endless, no tool is going to rescue you from that, right? That comes down to discipline and engineering discipline and product discipline.
It seems like there's also an opportunity in as you say in the consulting business in what you're talking about there. In that, if you there probably is some way that with the right kind of platforms and let's say like containment of risk, to use it, or you know whatever way that you could. When you're using code generation stuff, you could almost insert a lot more opinions and standards and like reduce variability because the developers like are operating above that, right? Like they're more just telling the thing how to combine stuff together. And then of course, as you were going down the security side road there, you do need an overall platform that like can then deal with that and like contain things.
Correct. So I want to alleviate the developer from the cognitive load of all that CVE and vulnerability stuff. So let's say I've got a magic wand and I can do that. Well, I still now have a developer that needs to understand, for instance, kind of wrapping on that AI thing that I kind of opened and forgot to close, which is, yeah, there's a whole lot of possibility there, but let's back out to something that's more structured. Can I have AI write all my unit tests as failing unit tests? And then, maybe some of them as unit tests that are passing. Maybe I can slowly figure out how AI can write a fully, maybe 80% there effective unit test for things that are missing tests. Because guess what I can do if I have tests? I can introduce change with confidence. And I know it seems like an old, dated concept. It doesn't need to be at every unit, but the major cases need to be tested. And what better place to get out there and kind of, cut your teeth on something a little bit cutting edge in a low risk, in a risk contained context. As long as I am acknowledging that those tests have been developed by AI and they're not yet a barrier to production until they've been validated by a human, I've just gotten a huge amount of lift from AI. And that's a really difficult use case. But what about an easier one? Pipelines. There's going to be tremendous opportunity for, hey, this is an app going to, for instance, Tanzu platform. What should the pipeline look like? And that question should not vary significantly based on the language. There should be maybe a step, which is build the thing.
What was I thinking? I'm about to lose my thought. Oh, the notion of having, the AI write failing test cases for you. That seems like a good start, right? Because it's easy to validate failure, so to speak, because it's failing.
Yeah.
So it's been successful at what you asked it to do, and then you can you can go through and figure out how to correct the things, right? It's sort of versus if every single test failed, you don't. I mean, sorry, if every single test passes, you don't actually know if it passed because it's all fine,
Right.
right? And
Yeah. Yeah. Wow. That is really
so
good.
that's a yeah, and that's highly relevant, right? Excuse me, because it seems like in modernization and legacy talk. I don't know. Tell me if you have much more experience than I do, but there's like there's two levels of the conversation. One of them is what we're talking about right now, which is just like, you know, your fingers on keyboards and mice, and you're writing stuff and you're coding and this, that, and the other. And the other one is like meetings, right? And like slides and like process and people and that kind of stuff. And they feel like those two things often don't mesh well. And a lot of the work, like I've seen from labs people over the years, and with things like the what does RPM stand for? The
Rapid portfolio
right.
modernization.
A lot of that kind of stuff. It seems like the success of that kind of modernization is when you bring together those two levels, right? Not only those shards that don't really talk with each other. That's a very I get my directions messed up. That's a very horizontal concern. But here, it's more like you're trying to have some vertical integration between the two. So, like, tell me how the RPM stuff works. Like, what does that process look like?
So, rapid portfolio modernization is a technique that was developed by the application transformation field back in the Pivotal days. What we did was we found ourselves kind of opening up text editors like a Visual Studio Code type thing, and doing, of course, back in the day it was Notepad++ or whatever. We were doing these massive regex searches through tons and tons and tons of code to find the common blockers to leveraging Cloud Foundry. Now, at the time, those common blockers were based on the 12-factor manifesto of these are the things an application, these are the attributes that an application must have in order to be cloud native.
So a blocker, just a blocker might be something like configuration is hard coded instead of passed in through environment variables,
right,
or other ways, or
right,
you're depending on the persistence of local state, or you
right.
have zero decomposition and there's just like one big executable you run that outputs one thing, or something like that.
Yep. Yeah, all kinds of stuff like that. I think the most common though is to the point you made about local persistence, session memory. A lot of things
Right.
that handle sessions and hold that session data in local memory instead of in a distributed cache or some shared resource. And we would see these applications that based on their code were a really good fit, short of a few problems. And we kind of started sorting things based in this, all right, problems we found in the code and ease of use to get on the platform, because our job is to get things there as quickly as possible. And kind of a few things came out of all of that. To make a very long story somewhat shorter, a few things came out of that when we were brought into VMware. So VMware acquired Pivotal. And here we were, this scrappy team that was just starting to use code analysis. So scanning large amounts of source code in order to form an opinion about an enterprise migration plan, which is kind of, 6 years ago, this just hadn't been heard of. It was pretty cutting edge. And so as we started leaning into this idea that your source code is the source of truth for your modernization planning, we also started to realize, and the timing here is somewhat unfortunate in that Kubernetes really started to kind of make a dent in the industry, but we started to realize that this 12-factor app stuff is a little bit preachy. Not every app that goes, so Cloud Foundry is a cloud native platform. No matter what app you put on it, that platform is cloud native, but not every app on that platform has to be cloud native. Right? These are orthogonal planes. The management of the application, the experience of the operator, how do we how do we track our pets, right? That's track and feed and all that stuff. That's one side of it. But then the other side of it is how do I how much care does this thing need to actually play in this destination? And we realized that 12 factors, which somehow ballooned to 15 when containers became a first class citizen, but 12 factors seemed even heavy. Ultimately, as the RPM team started to gel and we started to see more use cases, we realized there were only 3 factors needed for an application.
The 3 factors.
One is, that's right. So are all of its life cycle concerns automated? Can I build it, test it, package it, push it? Can I do that by pushing it?
I mean, these sound like very platform concerns, right? Like very life cycle and platform concerns.
Yeah. So can this application actually be built without people touching it and deployed without people touching it? That's criteria number 1. Is it possible for machines to push this thing all the way to production? Number 2 is, can I do that anytime I want? Regulatory concerns notwithstanding, if I'm Barclays, I can't just push code anytime I want. I got, regulators looking at me, et cetera, et cetera. But if that regulatory framework didn't exist, could I just push this app at any minute and it would be up and running? And then the third thing is there a pool of talent available to service the app?
Right.
So do I either have in my employ, or are there people in a broad freelance or contractor marketplace that can come in and support this application? If I can do those 3 things, writing in pure assembly code, I'm a modern shop. I don't know how that got pulled off, but
sure.
Look, pick your language: COBOL, assembly, whatever, C++, C. If my people don't need to babysit the code in order for it to go from code to executable, and my people don't need to babysit it for it to go from executable behind the line to executable in front of the line, and I have all of the people needed to make changes to that application as needed, it's modern. And so when you reframe your view around that and you scan, our record is 2 billion lines of code for a single customer. First of all, the first observation we had is, as a bank, you should not have 2 billion lines of code under your stewardship. At the time, Google had about 2 billion lines of code.
That sounds like the kind of thing.
So something is fundamentally
that sounds like the kind of thing that results from either being a very long-lived bank, or now you're actually 10 banks that have been acquired over the years. So you do have a lot of code.
I don't want to. I have to protect the names of the innocent, but one of those 2 statements was absolutely correct.
Yeah.
So
yeah.
What just the amount of debris is.
What is, I mean, so what you're going over is a good representation of what I was intuiting, is that there is this mixture from the low level, actual coding, up to like the people part, right? Like, and so on the people side, and is this like if you could only choose one of the 2, would you choose skills or like fluidity of what you'll do? Right?
So skills or flexibility,
right?
like,
because and I ask it that way because of course you want both. We all want both, right? Peanut butter and the jelly, maybe a little honey on top, on some delicious freshly baked white toasted bread. We don't want to get too Elvis there, but I look at a lot of surveys over the years, and one of the things all the time that executives say is they don't have the people or the skills. And I often think like, well, you could just buy an O'Reilly subscription and go read a book. I mean, that's a flippant way of putting it, but it's sort of like, yes, just set aside 3 months and people can learn stuff. And so like, now that said, I mean, I know skills are an issue, right? Like I can't really program, even though I used to be able to. I need to set aside 3 months, right? But I think a lot of it is also like there's something different that's sort of just like willingness to do something differently. I'm not sure.
I think you're you're tugging on an interesting thread there, because most of the folks that I have met that are absolute rock stars at what they do are absolute rock stars at what they do. And if anything pivots away from what they do or how they do it, discomfort becomes obvious, right? Versus that flexibility, which is, you know what? I may only get an 8 out of 10 from this person or a 7 out of 10 from this person every time I ask them for something, but I can ask them for something different every single time. To me, that's like an EQ trait that you're not going to find, an emotional intelligence trait that you're not going to find in somebody that is often so skilled in one area that they believe that that area is the only area.
Yeah. I mean, that's a very like what would you call it? Honest approach to people is people often are not is the word virtuoso, is that a musical jack of all trades that I could do a guitar solo and also like play classic violin or something and then do a harpsichord,
Right.
like it seems like that's not really how most people are at all, and they're very good at one thing. They're experts at one thing, and maybe one indication. I don't know what all the fancy like counterintuitive behaviorists and econ people like call this kind of thing, but like the fact that we talk so much, whatever this current 5 years we call it, but the T-shaped person is indicative of how that's not a real widespread thing, right? Like most people are I-shaped. I don't know what the opposite of a T-shape is, but I don't know. So maybe that's kind of what a skills thing is just like I have all these .NET developers, and now I need to program a bunch of Python because AI or something like that.
Yep. And I think it goes back to that again, to the very beginning of the conversation, which is, the purchase does not complete the use case. And oftentimes it feels like we've got these concepts inverted, that the people need to be changed out every 5 years, right? Instead of the people need to learn to adopt the underlying technology, which will be changed out every 5 years or at an increasing clip. I mean, you don't have anybody on your staff right now, more than likely, that's going to be a solid fit for that first quantum challenge that you're going to solve. But guess what's going to be in the next 5 to 7 years? You're going to be hiring somebody. They're going to be using a service that's going to be leveraging quantum. That's just going
to you're making me think of another interesting thing that in I think even average functioning organizations, there is a notion that at the management layer, a manager should cycle through different roles and parts of the company. They should get a broad set of experience because, as kind of ironically, as a manager goes up in the chain, they need to know more and have it's good to have firsthand experience with more things. I don't know why I'm saying that's ironic.
Oh yeah, I mean, losing touch is high risk these days, especially.
And so it seems like, let's call it management culture versus IT culture. In management culture, there's almost this institutionalization, which is that it's common sense that a manager should move around, and that's built into well-performing places and even just average performing places. Whereas in the IT world, it's not like, well, this year you're a .NET developer, and next year you're going to be a Python developer. And the point that I'm trying to make is that you part is the organization does a lot of that work to transition the people between the roles that they have, right? Like I'm sure it feels like this for a manager, but like a manager just doesn't show up on Monday after Friday, and now they have to run like a completely different P&L. Like there's help in transitioning and all sorts of stuff. Whereas like I guess maybe the notion with IT people is just like, as I was flippantly saying, is like, give me all your .NET books from your desk, and here's a box full of Python books. Have a good weekend.
Right. Well, and why isn't that the expectation within the bounds of reality? If you're gonna tell somebody, I've I've got to send you to Spain for 6 months, they're not going to be fluent in Spanish by week two. But if they give it a good shot and they're there immersed, they're going to come back fluent. But if these days it was, I need a .NET dev and I've got a Java dev, there might be a decision about, do I let this person go and hire someone else, even though they both know how to have a conversation, they just speak different languages. That's kind of, it's a weird place to be in if, as a manager, you've got the impression that folks that know one way of doing something will only know one way of doing something. I think that's a poor trait of a manager is to not believe that their people can rise to a challenge, even if that challenge involves developing new skills. That was, to me, one of the best parts about traveling around the country and working with teams, was kind of helping them realize their own greatness. I don't think a lot of teams understand how many problems they solve until you get them all into one room for a 16-week period like we used to do frequently, and keep track of all these things on sticky pads, whiteboards. There is a tremendous amount of work being done. Laziness is not something I have run into.
Right. There's that's something I often think about people in computers, is most of them got into computers because they liked it. They also like the money, but it's sort of like it's very difficult to get into like computers if you don't somehow motivate yourself to enjoy it. And
well, that's the double-edged sword of the developer, right? Is we love so much to create frameworks. Like, those of us that do this job because we love this job often find it very difficult to write something that should only work for one thing. To me, that is the discipline. That's the hardest developer discipline, to not write a framework for a problem that just needs good enough, and to understand, when does that problem need good enough versus when does it need better. That's one of the things that RPM does that's really cool. So when we ingest all of the code from hundreds or thousands of repositories, we're then able to perform some fun comparative analysis with that code and find applications that are structurally similar to each other. We call them archetypes. And so we group these applications with similar dependencies and similar runtimes. I like to call them piles of similar construction materials. And we do it that way because, first of all, people in trades have very specific skill sets that can be executed on to the highest degree of value. Right now, we're talking about the developer that maybe is learning Python but really knows Java. If I've got all of my portfolio sorted in common construction materials, I not only know where the easy Python is for this person to cut their teeth and get better at this language, but also where's all the challenging Java where I'm really going to need that person, because people are going to deliver your modernization project for you. People, like, AI will not do this. Managers alone will not do this. It is the whole team and the developers still writing the code to get that thing over the line. So losing sight of the fact that people write software, AI didn't just make that happen. I have heard, so interesting, right? We don't even question the term software developer these days. But in 1997, 95, when people said the word developer, they were talking about a person that was going to bring the money, right? A real estate developer, a commercial developer. Like, we somehow evaded the term engineer. And I personally think that gave us a lot of permission that we didn't have. By looking at these folks as interchangeable, somewhat moderately skilled people, or not even people, so interchangeably moderately skilled resources, right? Rather than people that have an intimate relationship with that code and perhaps other people. That big disconnect has been there forever. The idea that we're not engineers, we're developers. The idea that software that it's like Legos. Uh, None of this stuff is true, but somehow it all permeates to higher level thought about what happens at an IT company, or what should happen at an IT
Well,
company.
let me propose something here, which I think is like so. It feels like modernizing your applications is a lot of work, and the reason it's a lot of work in all dimensions is because, as you were saying earlier, it's a lot of like it's a lot of not only, let's call it, people work, but but going through the work product of people, which reflects them. I mean, you can, as you did, you can invoke Conway's law, which to kind of summarize, it would say that in the case of what I'm saying here, that the way that your software is arranged, the various components of it, the way it's architected, will kind of mirror. I know it's technically the way the communications pass, but it'll basically mirror what your hierarchy looks like, right? It'll be a mirror of
Yep.
your company, more or less, right? Like there's some footnotes and distinction, but I'll just move past that.
Which is why a reorg can break software,
Yeah,
interestingly. But maybe that's a
no,
whole other webcast.
excellent point, right? And now with the three factors, it seems like what is going on there is we need to identify, like you're saying, before you even get to the archetypes of applications, what is like the minimum uh, crap you have to remove from the system to do all that hard work. and definitely, like, can you build the code, right? And once you have the code built, can you like can you run the code in production so people can use it, right? And then the third is like, and then I'm going to even simplify the third one is like, do you have people? Right? Like
Right.
are
Right.
there people who can work on this, right? And can spend the time to, like, once you do fix those first two things, now these people can, like, I was going to say write code, but they can think about what the application needs to do and express that in code if needed.
Solve the
But
problem.
like, is that like when you're doing the RPM process? Do those three factors like clear out? Now we can do the real work once you put that in there.
So those are really going to be the guiding principles. So if I find something that looks like it's going to be a good fit for the platform, in that it doesn't have too much technical debt, the next factor that I'm going to weigh is, what does its path to production look like today? And if its path to production needs a lot of work, have I already done the archetype definition to know what's my ROI? So if I've got 600 other applications that look like this one that has no pipeline, and I've only got 5 others that look like this one, that has a pipeline, but it's not great. This comes back to that conversation of what's good enough versus that developer instinct to want to solve world hunger. If I have 600 applications and my portfolio is only 2,000 applications, that's 25% plus. Absolutely, it's worth a reusable solution. I'm going to be saving the company millions of dollars every time we talk about pushing this application. I'll talk about how many people didn't need to touch it. On the other hand, I got these 5 applications over here where if I spend 3 months automating the deployment of 5 applications, I am not a showcase of efficiency. My skills are very impressive, but how those skills have been leveraged on behalf of the company's dollar, your fellow employees, maybe investors if it's a public concern, those were not 3 months spent well, right? So it's about finding economies of scale. If we're going to solve a hard problem, let's make sure that we're solving it in lots of places. And the other really fun thing that RPM brings to the table is, because we know where a technical debt problem exists in code and which applications contain that problem, we're also kind of able to help developers understand what's the return that I can expect to get just visually. If I look at a diagram of apps that are similar to each other, I kind of get this almost like an ROI calculator I'm looking at problems to be solved, and I'm looking at how many apps they're connected to. And I know the ones with lower connectivity require less effort. So being able to gate, not everything gets the same level of effort. Not everything gets the same treatment. That's not a number one problem in modernization is folks seem to think there's one pipeline that things go through, when in reality, there are a number of states of readiness. And what we want to do is we want to find, again, problems and group them and do fun things like find a really hard problem that also exists in a really low risk system. So I've got this killer problem. It's in front of house. If I can solve it on a low risk system, now I've got a proof for my higher risk system, all just based on code analysis.
This seems like maybe this is the after the well, this is what you do with the 3-factor thing is you're engineering the organization change in that's the wrong way of putting it, but to put what you're saying, I think in what I think you're saying in my words is one of the things that I think is like all 2x2 methodologies, right? Like what the RPM process to modernize your stuff is doing is saying, all right, what is something that's valuable that we can be successful at modernizing in the constraints that we have,
highly valuable,
right? And like there's also things that are highly valuable and not really possible to modernize given the resources and constraints that we have. And then there's also things
usually
what?
Usually it rhymes with mainframe.
That's right. And then here are things that are very difficult to change that aren't very valuable. And so like, you want to early on, you want to find things that are valuable, that are easy to change, because I think this is part of like what's not really like the developer or even like the product manager or maybe even the architect, so to speak, however you want to hierarchize development. But it's not development or operations responsibility, is someone, that being management, or if you wanted to be fancy, you could call them leadership. Like management has to prove that this whole thing works and that it brings value. And so their job is to come up with a plan for not only introducing technologies like fixing up the build and getting a platform in there, but now they need to plan out like we're going to do this cluster of applications to show that this is worth it and that it works. Not only like as we in the whatever the agile space would be like to learn and grow and thrive, but more just like so I can go prove that we need budget for next year and that we should still exist and we should do more of this. Now, I think there's another effect that you probably talk with people over the years about this, but I end up talking with people maybe 2 years into like a whole platform journey or modernization journey, is they realize that they need to do a lot of marketing internally, and that identifying some initial possible modernization projects immediately feeds into that, because then you have what us sellers of technology would call case studies and customer references. And so that's the other part that's valuable to build up, that I think that management, that's part of the system they're building, is I can show you examples of other people in our organization being successful with this way of thinking and using this stack.
Absolutely. Yeah, I mean, nothing breeds success better than success, right? If I can have a team that is, and I think the word that really describes what you were going for is entrepreneurial, right? And I think that's something that's been lost in today's enterprise culture. In fact, the enterprise budgeting process reflects more and more kind of a sovereign or political budgeting process, use it or lose it kind of stuff. Like we're going to figure out what you need next year based on a meeting we're having this year. But that makes it really difficult for me to do something like maybe I've got a pool of 300 applications that rely on a legacy middleware. Some kind of service busy type solution from the early 2000s. If I can show through what we at Pivotal would have called the art of the possible, right? I can show through some math that these applications at the code level are very similar. So I've got that part covered. I can do some code analysis and show the problems in these applications are common. Then I can pick one and I can say, let's solve some problems, not with automation, not with fancy stuff. Let's brute force this sucker. And then let's figure out step one, can that brute force be backed out into automation? Right? Can it be backed out into a more generic approach? And then with the cost of doing that and the cost of, we'll use a stopwatch. How long did it actually take us to do this application? Now we're going to make a bold prediction. We're going to say, well, it took us X to do this one application. They're all of varying sizes, but there's 300 of them. So right now the number's pretty much a guess anyways. We're going to say it's 300X. That's what the budget is right now. And that's That's using actual data from the field, doing an application and getting a go, no go decision that results in valuable work at the other end anyways. Like I either get this application off of its middleware platform and I decide that's not worth the squeeze for $299 more, or I've just started a beautiful new project that's going to result in efficiencies in the next year and a half by taking these 300, kind of weird use case applications that require this old third-party technology, and I've now got them as wonderful Spring apps with REST endpoints, serving all the same old consumers that this other.
Yeah, I think you've drawn out kind of like what would you call it? I don't know, a kerchunking that happens in my head with one of the favorite phrases in our industry is like, technology is easy, people are hard. And I often think, well, I think to draw this out, I often think two things. One, if you're getting paid to use some tool, you should never say it's easy. You should always say it's very difficult, requires highly skilled people that are paid very well. Don't ask what's going on. It's hard, right? Like never trivialize the difficulty of the job that you're getting paid for. But two, less self-serving, although I'm fine with self-serving too. But two, I think the proper phrasing is, as you've kind of, I think, shown an example of here, is it's more that the bad technology is going to make the hard stuff impossible to solve, right? Like if you've got like a not great technology in place, right? Like you got all these different build pipelines, you don't really have a platform, or worse, you have tons of platforms. You're not really going to be able to get to that difficult part. You're going to be spending all your time dealing with this bad technology, right? Kind of trapped in that legacy trap, if you will. So, as the last question, I think we've kind of like referenced this and kind of like nudged up against it, but I think there was correct me if my memories are wrong, but I think in the 2010s, there was this notion of digital transformation. And there was what I'm going to get ahead of here is there was an urgency that was driving everything. And that urgency was, we used to have slides about this. The urgency was Airbnb, Tesla, Google, whatever existed back then are all going to come and take over your industry, and you're going to have more problems than mainframes, right? You're just not going to exist. And that, I think, drove a lot of people to just like install service buses. I mean, but it actually drove, my sense is it drove people to spend less time on ROI analysis and more time on existential crisis of we should have better software, right? And I think we all benefited from it, not only in being in the tech industry, but as users, right? Like people really don't like stuff that they use daily, but like I reflect on the software that I use from regular organizations and governments today versus in 2012, and it's so much better, right? Like the enterprise got the memo about how they need the software to be better. So my last question is, it seems like AI would be the natural urgency driving things like that, but it doesn't seem like it. Like it seems like AI is this different force that's not so much causing like this existential code or die situation, but there's something different there. So I don't know if we have that urgency that organizations need to like go through the change.
So first of all, AI has been around This is just the first time that the underlying stack is getting all of the attention. And I'll tell you, I have a digital assistant next to me, and I'm not going to say her name out loud, but she's been pretty popular for like almost a decade. And you know what's driving her ability to understand what I'm saying and give me a cogent response? AI. Has nothing to do with LLMs. Now, the company behind that particular product, they didn't have AI anywhere in the advertisements, right? Sell the benefit, not the product. So, like, sell the benefit, not the feature. The benefit is I talk to this thing, it'll play music if I want, it'll turn on and off the lights for me, it'll do my bidding just based on my voice. Nobody mentioned AI at all. Now, fast forward 7, 10 years later, whatever, we're all obsessed on the feature and not the benefit. And so it's going to have a very similar. I've been fascinated by the similarities to the Kubernetes adoption way, because Kubernetes wasn't a general public. You didn't go home and like a 7-year-old kid was like, "Oh, that's so cool! It was made with Kubernetes." Whereas my kid knew what AI was as it was becoming a thing and would comment on it. Never once was Kubernetes something that his elementary school mind was pondering or
it didn't make your cereal taste better. There was no connection between breakfast and Kubernetes.
Massive industry excitement. Massive. And even folks that didn't know what it did or why it was knew they needed to have it. Which, again, I think happens with AI, and it happens with AI in a different way, but it's really weird, right? With Kubernetes, it's almost as if we built my single family home here with steel girders, right? You use different construction materials for different levels of problem, but yet somehow everybody was convinced they needed a solution to a problem that really only Google and a few others have, which is how do I keep thousands and thousands of machines humming in synchrony, even if a dozen or two happen to fall off a cliff. That's not everyday work for even folks like me and you. We work at a pretty big company and we get to work with pretty big companies. Very few that I see need that level of orchestration in order to keep those applications up and running. But a lot of folks went to it because that was the thing. Now you got AI, and I'm wondering how many MCP, and MCP, for those that don't know yet, it's Model Context Protocol. Kind of think of SOAP for AI agents. How many things are going to have MCP endpoints stood up around them that don't really need them? And what is the danger in that versus a SOAP endpoint that wasn't really needed? Well, the thing driving the SOAP endpoint didn't have, quote, a brain. It wasn't making decisions on its own. This MCP endpoint is basically adding a blade to the Swiss Army knife that whatever AI agent is calling it. That Swiss Army knife that agent has now gets an extra blade because it's got this other MCP endpoint that it's able to grab another tool from. So as we start to stand these things up with less thought, and we start to put things out there that are capable of more thought, I think we're in for a rude awakening. I think that AI is going to be super helpful in upping productivity by doing work that humans find tedious done faster, not by doing work that humans find valuable. If you find that work valuable, question whether or not technology is the underlying value provider there, because it's probably your IP, your intellectual property, that is the underlying value.
Well, what I'm sensing here is we need an RPM process for doing AI projects and applications, right? You got to identify something that has business value, that's tangible, not just gratuitous is the wrong word, but you don't. Well, it is not just gratuitous MCPing all over the place, so to speak, right? Like, but that is for a purpose and is used in probably the existing business to make it better, and then getting the we'll just call it. We'll use this phrasing. The secret of the RPM process is, as you say, one of the axes is the art of the possible. What can we actually ship and be successful with, and going through and identifying those things, and probably what you'll discover is you have the same 3-factor things. It's like, well, you need a platform. Otherwise, you're going to spend a lot of time on that, and you're never going to get to like actually being able to fill out that 2x2 grid and like execute on it, so to speak. Which should be fun. We got to update some of our material. We're going to comb through the PDFs, do some editing here and there. well, thanks for being on.
Yeah.
It's a good discussion. It was fun. We got to. I think
Absolutely.
I'm always interested in kind of going between the. You got to modernize stuff, and it's a people problem, and trying to find like the tactical way of solving the issues, right? Like, what do you actually do? And I think we've bumped up against a few of them that are useful. What if people wanted to see what you're up to in the internet world? Do you have something you would point them at?
Yeah, you can find me on LinkedIn. I'm just Brian Friedman at LinkedIn. I'll make sure that a link is posted with the details on this chat. And I have a few blogs out there. One specifically relevant to this AI conversation about how to ship AI agents that are actually valuable. I got that one on Newsstack about a month ago. So I'll get some links up for this webinar. And I agree, this was a totally very engaging conversation and a lot of fun topics. Would love to do a follow up on just some of the things we're able to scratch this.
Well, I'm going to go off and I'm going to think that if MCP is like soap, I need to identify what the WS star of MCP is, and
right,
maybe it's JSON. That might be what it is. And my understanding, I don't really know JSON culture, but I think they like to use the word shape. They like to talk about the shape of the JSON, which I think is much different than the structure of the XML in the SOAP.
Well, every XML is a rectangle. So
that's right. And a JSON is more curly. It actually has curves to it, not just edges.
That's
all right. Well, speaking of, we'll see everyone next time. Bye-bye.